So our lab is focused on these three benefit areas where we think basically if we can make a shoe fit better, there are three main areas that we can improve in. It's endurance and health, agility and speed, and power and precision. And so our lab is actually organized into those three benefits. So kind of looking the long length of the lab, this first section we're in is the endurance and health section. So for golf, what that might mean is over the course of around 18 holes, you might look at performance over the course of the day. And so if somebody's especially walking those 18 holes, their degradation in performance as well as how the shoe fits while they're walking is really important. So we have this really fancy treadmill as well as these 4 cameras that allow us to measure force up to 1,000 times per second. And then we can measure these videos up to 200 times per second. So I can show you a model of what that looks like, but basically the goal there is we can calculate how force is traveling through your body. And in one of our first papers, which was more in agility and speed, what we found was in a BOA shoe that fit better than a laced shoe, people moved less, basically in unintended directions, right? So if you're trying to, for example, jump vertically, people had less motion at each joint in these other directions where it's kind of wasted motion. One of the other things we can do, and this is a little less relevant for golf, but we have this machine right here where we'll hook people up to these masks. So just like if you're familiar with the Nike Vaporfly study, yep. So that's exactly the same thing. And so you could measure those same variables while people are walking. If you wanted to measure basically how maybe tired somebody got, we could look at heart rate, we could look at metabolics while they're walking and up and down hills, like to simulate a golf course, and then have them come over to a different bay to hit some balls. So to give you an idea of 2 of the measures we take in this lab. All right. So this first one is actually a runner. And I'm trying to maximize the screen so you can see it okay. So we can see sort of this 3D reconstruction of their body, their lower limbs anyway. And then this graph down here is a measure of force. So this is kind of like a high school physics problem where you start out with looking at the force, and you know where all these different segments of the body are in space, and we can look at how force travels up those different segments. And based on scientific literature, we know some directions of force are better than others, right? So if your knee, for example, moves in or out, that's usually not a good thing. One of the other tools that we use in the same area is this pressure mapping. So this is actually pressure underneath of the foot. This is during walking on the right-hand side. And so we can see as somebody is moving, we can see where the pressure is underneath the foot. As you can imagine, this is something that's really important for BOA because pressure is really one of the things we can primarily change. So that's the main portion of our endurance and health bay. We'll kind of move over into the next one, and this is agility and speed. Within this bay, we have 4 force plates in the ground that are covered with tape, so you can see the 4 different outlines, yep. As well as the 12 cameras, so just like the cameras we have over the treadmill setup. Okay. We put those 2 things together to have people do movements really quickly, as well as we'll bring our hitting bay and our TrackMan into this area to look at data really smoothly. So our hitting bay right now is just set up outside of this area, but you can see TrackMan, and so this is exactly the setup we might use, but we'll just bring the hitting bay into this larger area here so we can look at how their body's moving over time. One of the things that's maybe a little less relevant for golf, but I always think is kind of interesting, is our in-house hiking trail. So not that I know of many golf courses that have some of these obstacles, but this is sort of one of the ways that we like to try to bring our in-lab experience out into the field. So we'll take some measures that we know are really robust in the lab. We'll bring them onto the field. Or sort of the field, if you will, where they're on that hiking path, and we'll see if those measures translate to slightly less robust measures, and then we'll bring them actually out into the field. And then here is an example of a golf swing, where we're measuring all those same exact things I was just talking about. So as you can see, the person's standing on 2 force plates. We can look at the force underneath of each belt. So in this case, the blue is their front foot, the yellow is their back foot. We can see as they start their backswing, they put more force into the yellow or their rear foot. And then once they begin their downswing, that force rapidly translates into the other side. And then the nice follow through. Now, as you might be aware, there's a lot of really interesting research about what's happening in the upper body. So things like X factor and X factor stretch. Those are measures that we take into account during our hitting, but we also look at some of the other measures, looking at during that downswing and at various points of that swing, are we changing the pressure underneath of the foot or on top of the foot to allow for more contact between the foot and the midsole? And could that be potentially some reasons why we might see improved accuracy or some more improvements in repeatability? So kind of all those things put together, I think one of the reasons we want to talk is these two shoes that were in development over the past almost 2 years. Kind of just to give you a background on the story of how we got to those was before we even really had our lab fully built, we were working with some golfers in here and we just characterized good and bad golf swings. So we had people come in, they were all pretty solid golfers, so handicaps under 10, and we just had them hit 60 drives. And we characterized what drives were good and which were bad. And we measured the movement of all their joints, especially their lower limb joints, as well as the forces during good shots and bad shots. So kind of a basic science approach to say what leads maybe to a good shot. And what we found as far as things that we could maybe affect were there's a certain amount of rotation that was optimal between the ankle, the knee, and the hip. If you had too little, then you weren't generating much power. And if you had too much, you generally tended to either hook or slice the ball. So our idea was, is there something we can do with our system where we could reinforce sort of this medial side in certain areas, as well as reinforce the lateral side to help maybe guide the foot so that when someone is swinging, it's happening so quickly so they're not necessarily consciously thinking my foot needs to rotate this much. But you have these reflexes in your body happening so quickly that if there are these contact pieces, somebody might sort of subconsciously know this is where I am in the swing space. So we really just came up with this hypothesis of let's try and reinforce these parts of the outside and then these parts of the inside. And so you'll see a lot of similar design features between the two. And then we went to FootJoy and Adidas and just explained our hypothesis. We said, we're not going to guarantee that this is the best thing since sliced bread or this is going to add 20 yards to your drive, but we found some improvements in, for example, precision. We found some improvements in players' subjective report of how the shoes felt. So we think there's something really here. So then we worked with them during the design cycle to, as they built factory samples, we'd bring them into our lab and test. And what was really neat about this was this is as our lab was growing. So the whole purpose of our lab is to work with our brand partners during the development cycle, test the shoes relative to some baseline that we did in the beginning and say we are making meaningful progress and the shoes that hit the market are actually going to improve athlete performance as well as they're going to have great qualitative feedback. So we did that with both of these brands and we had really good collaboration where we could say, okay, let's make some minor changes and even our in-house prototyping team. So we have a team of 10 people that can stitch down to the millimeter precision. And they can make these changes and then we can say, look, we tested it. We think we should make these changes. We'll make them and send it back to the brand and say, let's try this with the next round. And then really just have this collaborative cycle go until the shoes hit the market.
So with these shoes in particular, there was the Adidas model where there were 2 BOA straps for the first time, right?
Yep.
To try to create, again, more stability in that kind of midfoot region, right? Mm-hmm. So how do you take, as you're building this lab function out, how were you able to take stuff that you've learned from previous designs and implement them into this based on your hypothesis? Yeah,
so when we came and we started with our hypothesis, we didn't say anything about like where to put the dial. My expertise in that area is really just to say, here's a hypothesis about where to reinforce in the shoe. And then we work with brands to sort of implement their DNA, as well as work with our design team to say, here's maybe an effective way to do that. And one of the really cool things about BOA is because we work in so many segments, we can take learnings from snowboarding, from trail running, and say this is what worked well in these movements that for sure are different, but they might have some similarities. And so that's when we'll come up with some ideas and we'll work with the brand basically just to infuse it so that it works with their brand DNA. And so this is sort of what the result of that was with Adidas, and this is what the result of that was with FootJoy. And there are plenty of other differences, like this upper mostly is a leather, whereas this is a knit upper. Yep. And so all of those things need to be taken into account when we're designing, for example, the tensile strength of those panels.
And some of that has to come also that flexibility, that availability to do that within what you're also trying to design is because of the experience you have. I mean, doing more knits,
Yep.
doing more of the path to the BOA system with different types of fabrics, not just metal, but I mean, you've done it with knits as well with Adidas. So do you guys kind of have a good idea, especially with working with these brands like FootJoy and Adidas that have been involved with BOA for as long as I've been thinking about golf shoes? Does it help to kind of have a better sense of what their DNA is, so you're not guessing what they're going to come back with in terms of an application? You kind of know FootJoy kind of likes the back sometimes, and Adidas loves the side with kind of aggressive styling.
Yeah, that's for sure true. And I think with our brand partners that we've had these deep, long collaborations with, to your point, we know we're going to be at a good starting point. We also know that they're going to value our judgments. So our goal is obviously to make a product that gets to the market and is a very successful product. Sometimes that can be a really difficult sort of first hurdle with brands, is for them to say, wow, this sort of ingredient brand is trying to dictate a lot of stuff to us. But I think once we go through a couple rounds of iteration of these designs and give feedback, I think it becomes really positive. The worst case scenario for us is if we were to try to, not work with a brand at all until 6 months before a shoe is going to be launched, because then it's not going to be a great solution for anybody.
That's a good follow-up question then. I mean, with brands, obviously there's kind of only such a large universe of golf shoe makers at this point, but every brand could potentially come to you and say tomorrow, hey, we want to get involved with BOA, we want to involve that in our next release. How much lead time does BOA need to be able to work with a brand effectively instead of just feeling like you're slapping something on a shoe?
Yep, I think effectively is the key word there. So we are constantly working with these brands, usually about 18 months before a shoe gets to the market. From that, during that 18 months, that can start with a design brief of what do we want the shoe to do, and then that can involve 2 or 3 rounds of factory samples, both coming our BOA factory, or excuse me, our headquarters, as well as the brand's headquarters, for us to dissect down things like lace angles, as well as then test in our lab. So I would say typically we're talking about 18 months design cycle with brands. Sometimes that can be a little bit shorter depending on what the goals of the projects are, but I'd say it's a constant evolution, and we're always looking at what's the next year and a half look like within our lab. So a lot of times it's like once a shoe gets to the market, we're like, oh wow, I almost forgot that we're already testing the next 1 or 2 iterations of that.
This may be anathema, but is the BOA Performance Lab also able to kind of give some learning that can be applied to laced shoes? Because, I mean, obviously with the ZG21s, you've got this premise of lightweight, stable, spiked golf shoe. Is there something that maybe came from learning about how to apply BOA to that also may have informed the lace models?
So I wouldn't say we directly informed the lace models this time, but one of the goals that's really exciting about our lab is we want to be leaders in the biomechanics of fit. So part of that is a monthly newsletter that another person in our lab, Kate and I, write, where we talk about what are areas of biomechanics related to fit. And so some things, for example, like just simply measuring fit is a really difficult problem. And so one of the things we try to do with all of our experiments is either write about them, publish the data open source, publish the code open source, so that perhaps other brands can say this is a valuable way for us to measure fit. So maybe not directly, we're not going to say, hey, with this lace shoe, you should do X, Y, Z, but maybe with some of the work that we either publish or talk about, the measurements at least that we're taking in this lab can help trickle into making all shoes fit better.
I guess the follow-up question then is, with the performance that you're doing, you kind of ran us through some of the experiments that you've run and some typical kind of sessions with golfers. How can you simulate, I guess, wear and tear of a round? Where a golfer's at 3.5 hours, 4 hours into a round, as opposed to the third swing of the day, and how do you get to that solution?
Yeah, so that really fits into the combination of endurance and health and power and precision. So one way that we could go about doing that is having somebody hit 3 or 4 drives and then walking on the treadmill at either a steep uphill and then a steep downhill for a mile, and then come back and hit some more drives and repeat that process. We do have a wearable set of tools where we can take all of this stuff in the lab and we can actually bring it out onto the golf course. We haven't actually done that yet, mostly it's a really difficult biomechanics problem. You start getting different weather, all these other factors that make the small differences that we're looking for more difficult to find. But we could actually do all of this out in the golf course, and I think in the nice weather here in Colorado, a lot of people would enjoy that too.
Does golf in particular pose a set of problems about fit and performance because of all of the variables that you just mentioned that you can't control? Different types of lies, different types of surfaces, different types of grass, and how everyone just kind of responds to either pressure or being tired or all kinds of different parts of golf differently.
It's a good question. All of our segments, to some extent, do have those co-founders, we'll call them. And one of the really cool things about science is there's a whole theory about trying to figure out what's causative, right? So if you change one variable, whether that's the fit of the shoe, how do you know that that is directly what changed the outcome variable? The way that we mostly do that is by eliminating all those co-founders in the lab. And I'd say, if anything, that almost biases our results against BOA, because I think the qualitative feedback that we typically get from golfers, for example, is on an off-camber solution, something like this might actually fit a little bit better and feel more stable. But we're not usually testing in an off-camber situation. We're typically testing on that turf and that TrackMan setup right here in the lab. So there's no wind, there's nothing that could really perturb the golfer. But if we're seeing benefits there, we can sort of use our reasoning to say, well, if we saw a benefit there and we think that it fits even better in an off-camber situation, maybe the results would be bigger. So then we could take something like trail run and say the same thing. We might test a trail runner on the treadmill here, and that's not exactly going to give us the same readings that we're going to get in the trail. And we'll do both of those tests, but we feel that we need to do both because just making those assumptions, one, isn't the way we want to operate, and two, the in-lab experience just allows us to get rid of all those co-founders so we can really boil it down to what those benefits are.
And then I'm kind of intrigued about the run maybe we're about to see toward lighter weight spiked shoes. I think Adidas has found something here, and I'm sure they're not the only ones trying to merge the comfort people love about spikeless shoes with the performance they might be missing by going spikeless. Is how much, I guess, how far you guys see so far in advance, 18 months in advance, are you guys already seeing what those trends look like for the future of golf shoes because you're so far up front? And without giving it all away, what has you excited about what's about to come?
For sure. I think within the golf market in general, over the last couple of years, there's been this trend towards just a more athletic shoe. I think of, for example, my grandfather, he always basically golfed in like a leather stiff shoe, right? And it always had spikes in it. I think once you go to a golf course now, you're seeing a much bigger variety of shoes. So I think it's interesting. I don't think that you're ever going to see just the death of one of those, but I do see sort of this knit upper, the more athletic type shoe becoming more popular over the next few years, probably continuing that trend. But I think what's really interesting, and we see this in run as well, with a knit upper, it can feel really awesome, but sometimes when you're placed in challenging environments, it doesn't maybe hold you as well. So that's what I'm excited about, is as we go into these more athletic type shoes where it's maybe not a leather upper, you need this additional support somehow. And I think that's where we found we can make a pretty tangible impact.
And on the aesthetic side of things, as mentioned earlier, obviously you know too, but you guys have come up with different ways to implement BOA, not in a camouflaged way, but in a more integrated way as golf footwear has changed. So does that present some challenges for BOA moving forward? Because there are going to be more knits. There's going to be a more athletic looking golf shoe that maybe also feels a little bit casual.
Yeah, I'd say that's one of the interesting parts that luckily I don't within our lab have as much input on, the aesthetics. But that being said, it's obviously important. I mean, I worked in a running store for a long time, for example, and so I know dealing with consumers, it's critical that they like what they're buying. Otherwise, they're probably not going to buy it. What we really focus on is saying, what can we do with our configurations to make them perform better? And then work with brands to say, let's infuse your brand's DNA with this concept that we have, and let's make it look like a nice cohesive package. And I think, in my mind, these two shoes are pretty good examples of that, where it does have this clean top-down look, which is what a lot of people are looking for. But definitely our initial designs and all the things we're testing in our lab here are performance first, and then work with these incredible designers and developers from brand partner labs to figure out a way to make it look good.
To the other end of that, is there anything that you guys have researched, looked at that is way off the beaten path, way off of the map of maybe what an average golfer would go, okay, I'll buy that, just either for fun or just to see if it would mean something really tangible in performance that you could convince a golfer that would be worth it to try?
That's a really good question. And a lot of my peers in different companies' labs, maybe less so in the golf space, but they typically do work in that more like maybe inspirational 8 to 10 years out space. Our lab, what's really neat about it is we try to work a little bit closer to what's going to market. So I wouldn't say we've tested a ton of that. I will say with some brand partners, not necessarily in golf so far, but we've tested some concepts that are really out there. And those have been really fun because we say, hey, can we just totally fundamentally reimagine a shoe? And those have provided really great learnings. I can't say we've done anything in golf that's made people maybe go crazy or made us cringe yet because it's so far out there. But I think that's the cool thing, right, is we are always grounding the stuff we're doing in this lab to stuff that will come to market.
And does the power movement, I mean, golf's become more of a power game, obviously, for the last 20 years, but it becomes an increasing part of the professional game, and I guess to a degree, amateurs too. They all want to swing faster. But does that make the learning process with BOA more interesting because they're trying to extend the human performance beyond maybe what was conventionally more of a sport where you swung, more of a finesse sport?
I think that's an entirely a good point. So the way that we oftentimes look at golf, it's actually kind of cool, is we'll say there's some sort of accuracy trade-off, right, between power and precision. So you look at the long drive competitions, and these guys are hitting the ball incredibly far. And we actually even have a guy in here that tests very often, and he used to be a hockey player, and he can swing 115, 118 miles an hour. The reason probably that some of these people have day jobs is because it's not always as precise. So that's really where a lot of our research is focused, is saying, we're not going to add power to the system. We're not going to maybe make you hit it farther, but can we provide enough feedback so that as you are hitting it maybe 90, 95% of maximal, you're now hitting a little bit more consistently? Because that's really the name of the game, right? Like, I'm sure there are probably 10 times as many people that can hit the ball 350, 400 yards that aren't playing in the PGA because it's just not that repeatable.
That's an interesting point too, I guess, because people need stability to create power, right? So what are you finding in terms of trying to, for golfers who maybe want to be able to generate more power, what role does a proper fit play in making sure they can perform that full body movement that makes that possible?
For sure. So one of the things that we measure within that whole biomechanical variable, so just again, thinking back to this whole skeleton approach, when you think of work, this is basically the amount of power that's being put into a system over time, right? And so there's an amount of work that's done between the shoe and the ground. If, for example, you have a really sloppy fit, and so let's just, for sake of imagination, imagine you're a size 10 and you're wearing a size 15 shoe. Your foot's probably going to slide in there. And we can actually calculate that work pretty robustly. We can say, wow, in order to do this movement, you needed so much more work because your foot was sliding all over the place. And so there's a lot of biomechanics research that looks at this, what's called footwork in running. There's a little bit less in golf, but that's one of the areas that we're starting to explore a little bit more, is understanding if a foot shoe doesn't fit that well, you're probably losing some of that power in these other directions, and it's causing you to do more work just to try to hit the ball as hard as you can. Like you said, for the longest time, golf was about finesse. And I still think the best golfers that we come in and test, they don't swing at 100%, but they try and find what's that maximum percent that they can swing at while still maintaining their accuracy. And that's where I think a proper fit is critical.
Yeah, I agree with that. I think you're trying to find the most repeatable, most powerful combination that's available, because then you're going to get the most out of it with the least dispersion. Do golfers that you test with, where do they try to maximize, or do most golfers try to maximize performance, not thinking about that, not thinking about the most repeatable thing, but going after it? Because I'm kind of more that golfer versus maybe someone who's a little bit smarter, I guess, as a golfer, and does what we're talking about of trying to moderate swing speed for repeatability?
I think we get golfers that run the gambit. And I think that will be really interesting maybe as we think about differentiations between clubs and shoes and, sort of personalized recommendations for what to buy. Could it be that somebody that their setup is they try to hit the ball as far as possible every time? Maybe they need a different kind of club, they need a different kind of shoe and a different kind of fit compared to somebody that they recognize max power maybe isn't their thing, but they're that more strategic player that every time they try and hit the ball a certain distance, that is like 70% of their max, but they know exactly where the ball is going to go. So we've seen both of those in here.
Is that maybe a potential future for footwear, not just for golf, but for sport, of toward the type of person that you are, the type of athlete you are, different set of demands or different set of needs, and for certain pieces of performance could help you one way or the other?
Personalization of equipment, I believe, is going to only continue to boom over the next couple decades. I think with the insights that we can gain with the addition of more data, better ways to understand that data, it's only going to improve. So we're starting to see that, for example, in running footwear. So when you look at like marathon racing shoes, you see originally there's this big infiltration that most people were running better in these sort of super shoes that have a really high stack height and they've got this carbon plate. But then as more research has come out, it really actually depends on your goal pace. So some runners don't respond as well. And maybe it's just that there's always been this change in response depending on the type of shoe. We just haven't measured it before. And so I think that's one of the things that as labs like ours become more ubiquitous and bigger, we're going to start seeing this personalization that optimizes performance.
That's awesome. I think if that doesn't give people everything they want to know about footwear, then I feel bad for them. But thank you. This was really cool. I wish I could be out there in person and see this. And
when this is all over, I'd love to have you out. We'll hook you up with all the sensors and get you a video of you swinging.
It'd be pretty awesome. That's pretty cool what you built out. And I didn't want to interrupt you while you were talking about the trail, but I've been on parts of a golf course that looks somewhat reminiscent to that. So I wouldn't say that doesn't exist in golf.
For sure. Yeah, no, I mean, we definitely built it more towards like hiking some of the 14ers around here, but I could see some courses like even Fossil Trace around here maybe has some more gnarly parts.
And so last question, and this won't be video, but how has the pandemic changed your work?
I mean, biomechanics, the bio part of it, right? We need people. So in the initial stages, I'd say, from March until probably May last year, we were not testing in the lab. It did force us, though, to do some outdoor testing where we felt like it was still pretty safe. So we were taking some of our wearable sensors that we already had, but we just hadn't put much reliance on them because we didn't need to. And we developed some protocols where we can do tests in the field. So for trail running, for example, that was basically the only way we tested trail running in the summer was in the field. And I actually think it was fantastic. The shoes, people got great feedback. I still think we were able to provide input into designers, developers. From the other side was recruiting became more difficult at first. It sort of opened up again, which has been really helpful. But for a little while, we were just testing a small pool of people because we didn't know what was safe and what wasn't.
Yeah.
One of the cool things about biomechanics in general as a field is it's kind of young. It's sort of like, for example, my background's in math and engineering, but then there's also a whole like biology and physical therapy side of things. And all of these fields sort of trickle, they're growing in their own right, and then they're trickling into biomechanics. So we were able to use some of those early months to say, what are some revolutionary maybe methods that we can use? So one of the things, for example, we took from the MRI literature, like brain scans, is we can compare those pressures that I was showing you underneath the foot between different swings, and we can actually compare them just like somebody in an MRI technician might compare different tumors or something like that. So they're both images, and we're just trying to say, okay, at this point, what's different about these two images?